Hey everyone, it's Frank. Okay, so we've made it through the last exercise, and I think we're going to go ahead and we're going to tone it down a little bit more. This one's going to be a little bit more guided and kind of walk through, as opposed to the self-guided thing that we had with the last exercise. So today we're going to be talking about roadkill. Okay, not really what we're going to be talking about. We're going to be actually talking about advanced vector analysis, and this is we're going to get into some things like wildlife, habitat range, and protected range overlays. But the venue that we're going to use to talk about this is we're going to do a project on roadkill. It should be a lot of fun. So let's take a look at our exercise here. So for this module, we do have another quiz, so do please go ahead and read the vector analysis chapter, which is included here. This is a separate document, so please do go ahead and read the vector analysis chapter here, and then go ahead and participate in the quiz before we move on to the exercise. Um, when you go ahead and get your map ready to go, you can there's some answers that you can go ahead and answer here, um, and submit the document here along with the map that you're going to be creating for this exercise. So just to show how we're going to do the exercise today, I'm going to go ahead and take you through this, and we're going to start off by downloading our data. So we're going to go ahead and we're going to download our source data here, and I've already downloaded that into my module 4 directory. So I'm here in my LRS 505 directory, and I've got a directory set up for module 4. Remember, take good care of your data, and your data will take good care of you. So a good organized data file structure is going to help you find all the stuff that you're looking for, especially when you're working on your professional paper and all. So that should go beyond even just this class. All right, so let's go ahead and start off with extracting out the data out of the zip file. And I'm going to go ahead and do that because I don't need that extra directory. And here we have, because we end up with an extra directory again. Okay, so we've got our 3 different layers. We've got our statewide roadkill observations. We've got Idaho protected area districts, and we've got a shapefile for the Idaho state boundary. Once again, these are in shapefile format, but that's going to be just fine. Q is going to be able to handle shapefiles just fine. So I'm up here in Q, and oh, I seem to have lost my my data browser. Don't worry about that. That's just fine. So just keep in mind that there's always a way to bring these things back whenever if something's accidentally gotten closed on you. And so in this case, I'm just going to go on up to here to view, and I'm going to go to panels, and here's all of our panels, and I just want to go ahead and open up my browser, and here's everything that I am used to seeing there. So let's go ahead and look inside my module 4, and you can see I've already extracted my advanced vector source, and I'm going to go ahead and let's go ahead and start off with taking a look at the Idaho state boundary. Now, actually, I just wanted to bring your attention to this. If we go ahead and take a look at the properties of the Montana State, oh, nah, that property. Where is my layers? Let me go ahead to my view. And where is my layers? There we go. If we take a look at the properties here, and I want to take a look at my coordinate reference system, which is right here. So you can see that this is in EPSG 3857, WS84. And you'll notice that my map itself, if I were to go ahead and take a look at the map, well, okay, so the map itself is in, oh, here we are down here at the bottom right hand corner. You can see the map itself is in 3857. That is set the first time you add a layer. So the first layer that you add into a map actually specifies what coordinate system the map is going to run in. And the reason I'm bringing this up is because if I now go ahead and I look at my protected area districts, these are areas that are protected for various wildlife here, and I'm going to go ahead and add that to my layer. And so here you can see that now Q is actually asking me about what sort of what sort of transformation I want to use to go ahead and transform my data into the system here, because the data here is in well, ESRI 102039. It's an equal USA contiguous Albers equal area. It's in a different kind of projection here. So what we want to do is we can take a look. And okay, so the accuracy here for the initial transformation is 4 meters. That's not bad. We could go ahead and use this Canadian one. It's going to report 1.5, but it's not really meant for that. In fact, as we click around, you can see that the little down here in the lower right-hand corner, the area where this is relevant gets highlighted. And so we want to stick with an area that is relevant to the Idaho area. And none of these are really relevant, so I'm just going to go ahead and I'm going to stick, even though it says that the accuracy is 4 meters rather than 1.5. Let's stick with one that's actually covering the area of our map data in question. Okay, so I'm going to go ahead and I'm just going to go with the default here, and I'm going to say okay. And now we have added our protected area districts. Very nice. Okay, and what was our third layer? We have a layer here called Idaho Roadkill, or Statewide Roadkill Observations.csv. So that's not a shapefile, so let's go ahead and open that up, and let's add that to our layer. And you can see that this is actually opening up as a table. This is not a shapefile, this is a table. And if we take a look here and open up our attribute table, it's taking a bit because this is a fairly big file. In fact, yes, this is a very big file. It's got 55,000 records in it. So as you can see, it's got some coordinate data in the table, but it's not actually a shapefile. In fact, let me drop this out of here real fast because we're going to need to go ahead and treat this differently. So I'm going to go ahead and remove my layer. And let me bring up this up. Oh, no, I was in the right one. If I actually, so since it's a CSV file, so I just kind of wanted to show you what good a CSV file is. It's actually got some really nice qualities. For one thing, if we wanted to, I've already got this mapped to Microsoft Excel, and Microsoft Excel is perfectly happy to go ahead and treat a CSV file, okay? And so we can open up a CSV table, and now CSV stands for it's a comma delimited text file. There's other ways to delimit, but the CSV file is generally a comma delimited text file. If I want to do some tweaks to the data, I can go ahead and I can open it up here in Microsoft Excel, and I can edit and make some tweaks to the data before I even open it up in Q. So it's a nice interface for bringing in some edits before we even enter into the GIS interface. In fact, the CSV is a flat ASCII file, and if I want to, I can even open up in the text editor, and I could even look at it in the text editor if I were so inclined. Let's say, for example, I know that there was a misspelling on a species name. I could go ahead and open up in a text editor to go ahead and do a quick find and replace and fix the spelling error within the file. That's not what the goal is for today. I just kind of wanted to show you what a flexible format CSV is. So even though it doesn't open up right away in Q, it doesn't mean it's bad. It might take an extra step, but it's actually quite a flexible file format. So I'm going to go on back in here, and since I know that we need to treat this a little bit differently, I'm going to go on into my source manager, and you'll see that there is a tab here for delimited text. And so I'm going to go ahead and I'm going to choose my delimited text file. Go back here to my module 4, and it's already looking for a CSV, so I'm going to go ahead and open that up. Now you'll notice that there are a couple of different forms of coordinate system in here. I've got these X and Y coordinates, and I'm looking at them, and I know that these are, likely in some sort of a metric format. These are projected coordinates, but I don't know what system they're in. These could well be, for all I know, these could well be in some sort of UTM. They could be in some sort of state plane system. I'm not certain what coordinate system that is. I need to find the metadata in order to know what the coordinate system is here. However, you'll notice that the data also came in with latitude and longitude, and Q is going to be very happy to treat those as WS84 EPSG 4326 is the code, as opposed to 3857 is the code here. So I'm going to go ahead and go with latitude and longitude in this case, rather than worrying about those X and Y coordinates. So if I go ahead and add that, and that added them very nicely. And now for my CSV file, you'll notice I have got my points. Now this is here as essentially just a visual representation of the CSV file. In fact, I mouse over and you can see the path there. The path is still the path to the CSV file. So I need to keep in mind that just because it looks like a visual representation doesn't mean it is. I want to go ahead and I want to make that into a visual representation at some point, or into an actual data layer. But I think what I want to do, you'll notice that the points are going well outside of the boundaries of Idaho, and I want to do an Idaho roadkill map. So let's go ahead and let's clip this data to the state of Idaho. So I'm going to go on up into data processing, and the tool I want to look for is clip right here. Now there's a few different versions by raster. Some of these we may have played with around a little bit already in previous exercise. I'm going to go with the vector overlay clip right here. And you can see this other one is clip by extent. I don't want that. I want to clip to the boundary here. And so I'm going to go ahead. I'm going to clip my data. So I've got my statewide roadkill observations. My overlay layer is going to be Idaho state boundary. Okay. And I am going to go ahead and I'm going to, instead of creating a temporary directory, and I could go ahead and just name a temporary directory, but I think I'm going to go ahead and I'm going to output this out. So let me go ahead and save this to a file. And yeah, let me get back into my 505 module 4, and I'm going to go ahead and call this Idaho roadkill. Okay, Idaho roadkill.shape. Since it's going to be a shape file. All right, I'm going to go ahead and run that. And oh, that hit me up with an error. So there's several different levels of warning and message that you can get here. This one is an error, and it's actually going to stop me from doing it. So I need to do something about this before we can continue on with the exercise here. So let's take a look. And okay, so I've got feature could not be written, attempt to write a non-point. Okay, this is a multi-point geometry. Shape files do not support multi-point. So I know that this isn't actually a data, it's just trying to write something out into a format that's not supported in shapefile. So instead, let me go ahead on back here to my parameters, and instead of a shapefile, why don't we save this to a geo package instead? So I'm going to go ahead and I'm going to write this out to Idaho kill geo package. Okay, layer name is going to be, oh, hang on, that's wrong. There we go. So let's go to geo package file. Okay, and I'm going to call this Idaho roadkill geo package. Okay, so switching off to the geo package, it's a more flexible format. It can definitely handle those multi-points. So let's go ahead and run that. And you can see there's an error here for no spatial index, or it's a warning, but not an error. So it's still let me go ahead and run it. Go ahead and close this, and if I turn this off, there we go. So now I've got all my points, and they are just within the state of Idaho, just like I like. So I'm going to go ahead and get rid of this one, remove that layer just for clarity's sake. Very good. And let's take a look at my data. So I've gone from 55,000 records down to, let's see how many we've got, down to 55,000 records. Okay, so I've eliminated a couple of hundred points. That's okay. My next elimination here is I want to actually deal with a particular species. So you can see we've got Idaho has kept a really nice record here of different vehicle species interactions here, and boy, it's just a whole bunch of different species here. We've got domestic cattle, white-tailed deer, mountain lion, American black bear. Um, from my experience, well, not from personal traumatic experience, fortunately, I think the last critter in the world I want to encounter with my vehicle is a moose. So I'm going to go ahead and check moose. I want you all to go ahead and uh, choose your own species. Don't worry about the fact whether you actually end up choosing the same species that another student does. But I'm calling shotgun on moose. So I'm going to go ahead and do moose. You guys go ahead and pick out your own other species here. So I'm going to go ahead and I think we've got some records on moose. Yep. All right. So there's a couple different ways that we can go ahead and we can restrict our data to just moose. The first and kind of most straightforward way would be here in the table. I'm going to go ahead and go to select feature filters here. And I can go ahead and I can select, what was the name there? So if I go ahead and I select species, and I can go ahead and type in moose, and I can go ahead and I can choose moose there as a species, and I can go ahead and I can select those features there. And now if I go ahead and I take a look at my map, you can see all the little yellow dots are selected moose features. So now I could go ahead and I can right click to here, and I can go ahead and say export and save the features, save the selected features. And I can go ahead and save my selected features out as a new layer for just moose. So that's kind of maybe the most straightforward way to do it. What I would like to show you is kind of a slightly more subtle way of doing this. It allows us to interact with just a subsample of our data without necessarily having to create a new layer every time we want to take a look at the subsample. So let me go ahead and clear my selection out, and my buttons are all really small for some reason. I need to try to figure out why that is. Where is my clear selection deal here? All right, I'm going to have an easier time if I just get back into the table. And open up my table. I'm just going to go ahead and clear my selection from there. So yeah, so go ahead and deselect here. So the other method I want to use is I want to go ahead and select just a subset of my data using a SQL query. So I'm going to go on into, from here I'm going to go to filter. And this is a nice little interface for doing this. I think it's a friendlier interface than what we see there at the table. And I'm going to go ahead and I'm going to create myself a little SQL query here. So I'm going to go ahead and double click on species equals. If I highlight species and I say sample, it'll give me kind of a sample of the different species that are available. If I say all, I'll make sure I get all the different values in there. So I'm going to go on down. I'm going to look for moose. There it is. Moose, there it is. And I know some of you have a biological background. I apologize for not using the Latin. It's hard for me to call a moose an Alkes americanus when I just know it as a moose. So I'm going to go ahead and test that. Good. The where clause is returning 1300 records. So I'm going to say okay, and let's do that. And now I've got a much reduced version of my moose layer. Very nice. In fact, I come on and take a little test of this here. We see all these moose, and let's take a look at it with an OpenStreetMap on there, and get that to the background. And yeah, if I go ahead and I zoom in, I can see that these lines of moose are generally all along generally all along roads. In fact, the kind of the more major the highway, the more moose dots we've got. So yeah, this does appear to be a record of vehicle, uh, vehicle animal interactions. We've got some that are kind of um, off there into space, but that's kind of data noise, and we're not exactly certain what the source of this data is. So there's a good understanding of what's going on here. So what we have is we've got our state of Idaho boundary. We've got our protected area districts within Idaho, and we've got our Idaho roadkill. Okay, so I want to go ahead and now the next step is for me to go back to D2L here and go back on into the class. And the next thing that we have is our species range data. That's accessible from here or from the content pane. We can go on into our species gap analysis species data download. Now this is the gap analysis, and that is not very nicely. I just had it open before. Go ahead and try opening that one more time. Okay, never mind. There was something up with that link, so let's just go to it from the link from the web page here. And I know that this one is working here, so I'm going to go ahead and open up my gap analysis here. Okay, it looks like it is just taking a second for it to download here. I'm not certain why that was, but hopefully it'll be behaving a little bit better when you guys are accessing it. So we want to go ahead and we want to be looking for the species range and protected habitat data. So go ahead and give that a look, and let's go ahead and download our species range and predicted habitat area. And it's up, and what we have here is a nice little interface here for searching for boy, all sorts of different species. So I'm going to go ahead and I want to search for moose, and goes right to it. So I want to go ahead, and I don't want just the habitat model report. What I want to go ahead and do is I want to download the range data for right now. So range data is what we're going to look for. We can look at the habitat data a little bit later if this is relevant to your project here. So I'm going to go ahead and download the species range. And I have my species range here. If I go ahead and bring it into my project, it's going up into here. I'm going to go ahead and extract this out. Okay, and here I can see I'm getting moose in CONUS range, and this is the range as of 2001. So let's go ahead and let's look back at this in my browser, and we may have to go ahead and give this a refresh here. Refresh it. Now you see I already did my extraction here. What I do want to point out to you here is I want you to be mindful of this when you are looking at data that's coming in from a shape file or that's coming in a zip file. You can see that I actually, when I extracted this out, they actually had a zip within the zip. And it's a little bit of I think it might be overstating it to call it a fluke or a quirk with Q, because they definitely engineered it intentionally. Q can actually look at and access data that's inside a zip file. So I can actually go inside the zip file within Q, and I can add this shapefile here to the project here right from the shapefile, right from the zip file, and it will be visible. The problem with doing that, however, is that it will also be read only. and that's not going to help me out here. So I actually really want to bring this out. So I need to go ahead and extract out the data outside of that zip file. So I'm going to go ahead and I'm going to extract all this data here, and there. And now if I go ahead back into Q, so looking outside the zip file, here I've got my shapefile data that I want to go ahead and add in. No, that's my Idaho roadkill. I want to go ahead and add in. Let's take a look at what happens if I add this. Once again, it's giving me the question about the transformation. I'm going to go ahead and go with that. And here I have my moose data, and that is North American moose data. You can see that is quite a bit more than just Idaho. So we're going to want to go ahead and do another clip. All right, so I'm going to go ahead and I want to clip out my data. So I've just got the Idaho moose range. Now you can see Idaho is pretty moose friendly. Seems like it's mostly moose habitat, but I still want to go ahead and get that clipped out. So let's go ahead and run our clip tool one more time. I want to choose my state boundary, and I'm going to go ahead and I'm going to save. Let's do it to another geo package here. And I'm going to go ahead and call this Idaho moose range. You'll notice I'm never putting in spaces. Underscores are best when naming data. And so Idaho moose. Let's run that. And there we have it. We now have, and if I go ahead and I reorder this properly, we can see that we have state of Idaho, and a subset of the state of Idaho is the portion of Idaho that is habitable for moose or favored for moose. Within that, we have the protected area districts for wildlife protection, and we have our data on Idaho roadkill data. So we've got all of our pieces in place, and it's time to go ahead and start our analysis. So in the next video, I'm going to go ahead and we're going to start doing some data formatting. So we've got everything kind of into the project. Still going to take a little bit of formatting to get the data ready for analysis. So that's going to be our next step in the next video. So join me in video number 2, and we'll get started on formatting our data.